Hey guys, so I'm just waiting for a few of you guys to join me on the live and then we can get started. So we can get started in a few seconds. So if I'm audible on the side, just let me know. So or you guys can hear me that side. Okay, so am I audible that side? All right, thanks. So I guess we can get started. So my name is Tumakhosi Aime. I'm the current DSC lead for Botswana Accountancy College, and I'm also the GitHub campus expert. So in today's session, we're looking more into Git. I want to get more into the Git CLI. All right, thanks Hope, thanks Kiss and Joseph. So I want to get more into the command line interfaces and all that. So I'm just gonna touch into like the basic Git introductions, Git commands, and everything that you can do using Git and GitHub. So as I said, I'm Tumakhosi Ame, the current DSC lead and the GitHub campus expert. So I can see more of you guys are joining the live. So I guess we can get started. All right. So this is just the introduction to Git, what you can do with Git, what Git can help you accomplish, and yeah, all that. So first, before getting more into details of Git, so as most of us know, so if you don't know, Git is a version control system. So first, before getting more into details, let's look at the types of version control systems. So the first one that we're looking at is the centralized version control system. So in this case, the centralized system works on a client-server relationship. So the repo is located at one place and it provides access to many clients. So in a case where you're working on like a huge project that multiple developers are working on it, every developer can have access to, uh, let's say the master branch in this case. So you just have one place and then it provides access to all the people that are working on that one. The project managers, the developers, everyone that's working on that project can make like changes that can affect everyone. So if I make a change, it's gonna affect the other one on the other side as part of the project. So and then we have the centralized and then we have the distributed version control system. So in a distributed system, in a distributed system, every user has a local copy of the repo. In addition to the central repo, the repo is more like a folder. That's short for repository. It's more like a folder which holds all your project files, images, code, documentation, and all that. So in this case, every user has a local copy of the repo in addition to the central repo on the server side. So there's the one central repo that on GitHub on the cloud, and then you have a local repo that's on your computer. So you make the changes on the local folder or the local repository that you have on your computer. And then that's when you can add your folders, you can add your files, you can add your code, whatever changes that you make to the documentation and the project as a whole. And that's when you can add those changes and then you can push them to be reviewed and merged into the central repo. So all your changes in this case happen on the local repo first before they can be merged on the central repo. So then let's get into Git. So what is Git itself? So Git is a distributed version control system for tracking your changes in the source code during software development. So it doesn't have to be code only. You can make changes to documentation, to any file that's there on the like to any files that are there that are part of the project. So in this case, you can have like the master branch, like is there on the image. You can have the master branch and then you can create like multiple branches for any feature that you want to add. So if there's like a new feature that you want to add to the project, you can just create a branch for that one and then push your changes to that branch. And then after you're done making those changes, when you're satisfied, like, okay, now this is the change that I want to merge to the master project. That's when you can request for your branch, for your code that you made to be merged into the master branch, and then it can be like one version of that project. So, by the way, so if you don't understand something or if you want me to clarify something, you can just let me know on the comment section. I can see all your comments aside. So then under Git, there are two main states. There's the untracked state and then there's the tracked state, where your files can be under these two states. And then under the tracked state, your files can be under these three substates. So under the track one, your files can be under the staged state, they can be under the committed state, and they can be under the modified state. So on the next slides, I'll be getting more into these three states under the track files. No, under the track stage, not the file. So what is tracked and what are they, the untracked files? So in short, we can see the tracked files are the files that Git knows about. So Git knows that these files exist. You have made changes to these files or you've made changes to these files and you want to merge them to the remote repo. And under the untracked files, this is just everything else on a computer. So any files in a working directory that were not in your last snapshot or in your last commit, or you didn't add them, I'll be getting more into like the basic Git command that you can use. So the files that you didn't add to your commit are under the untracked files. Git doesn't know that these files exist, and so it's just like everything else on a computer. So then, let's get more into the staged file. So as I said in the last slide, there's the untracked and there's the track state. So under the track state, you can have staged. You can have these three here. You can have the staged, you can have the committed, and you can have the modified. So let's get more into stage now. So a staging step in Git basically allows you to continue making changes to the working directory. And then when you decide that you want to interact with version control, it allows you to record the changes in small commits. So you make your changes to your local repo or your local copy of the project. You make your changes on that one. So Git doesn't know that those changes exist. It's not aware of what you've made on a local repo. And then now when you want to interact with Git, when you want Git to know that you've made changes to this particular file and now you want to add it to the remote repo, you can just run this command here, the git add. So on the git add, you can either add a single file or you can add all the files that you've made changes to. So if you run this command here, now your files move from the working directory to the staging area. And then after adding this file to the staging area, you can either choose to commit those changes or you can add them to the staging area and continue making changes to some other files and then add them, then you commit. You can add this, push them as a single commit, and then make changes to some other files and add them as another separate commit. So let's take an example for these three files. So suppose you have edited the three files. You have a.html, b.html, and c.html. So in this case, these are just some basic HTML files. So after that, you need to commit all the changes that you made to a.html and b.html. So in this case, you're just taking these first two files, the a.html file and b.html file, and then you add them and you commit them as a single commit. So these two files are separate from c.html. So you add these two files, a.html, b.html, as a single commit, and then the changes to c.html, these ones were not logically associated with the first two files. So c.html is added as a separate commit. So let's take an example now using using these basic commands. So I said we have these three files, but now you want to add a.html and b.html as one single commit. So you can run this command here, git add a.html. This command here adds the two files to your staging area. And then when you run the second command, git add b.html, this one right here will add b.html to your staging area. And then after adding this one, now that these two files are under your staging area, that's when you can run the git commit. The git commit have changes for this right here under the codes, between the codes. This like the commit message, more like a label notifying other developers, or sort of a message that lets them know what changes you made. Okay, just letting them know what changes you made to these two files. And then you add c.html. So first, a.html and b.html were a single commit aside. And then if you run git add c.html, and then after adding c.html to the staging area, you commit c.html. And the commit message in this case is just unrelated change to C. So c.html is unrelated to these two files here. So this is basically what I said here. A.html, b.html, and c.html. The first two files, you add them as one single commit, and then the third file is just a single commit on its own. So they're more like separate. So this right here doesn't have to be this way. You can choose when the commit message that you want to use. So this doesn't just work on HTML. So let's just say you use JavaScript, index.js, and you've made changes to that one. You've made like change the name. So your commit message can be change the name for like the heading, the navigation, or whatever change that you made. Just add a commit message that every developer, everyone who's part of that project can understand the change that you made. So now we have the committed state. So as I said, the commit command is used to save your changes to the local repo. So first you add your files to the staging area, and then when you run git commit, you are saving your files to the local repo. So you have the local repo and the remote repo. So if you run this command, you're just basically saving them to your local repo. Note that you have to explicitly tell Git which changes you want to include in a commit. So you can't just run git commit without running git add first. You have to tell Git which files you want to commit. You can either add all three files as one single commit, or you can add the first two files first and then add the third file like a hello. So it's up to you which ones you want to add and how like your project is structured, which change you made. So then we have the modified files. So as you edit your files, Git sees them as modified because you've changed them since your last commit. You've added your files, you've committed your files, and then you change some other files. So those files are modified and Git sees them as modified. So since your last commit, you've made a few changes to those files. So as you work, you selectively stage these modified files, and then you can commit all those stage files. And then the cycle repeats itself. The new changes that you make fall under untracked. You can add them to a staging area, commit them, push to the remote repo. So why Git? Like, what can you get from using Git? And like, so if I'm moving too fast, you can just let me know if there's something that you don't understand. Just let me know. So why Git? What can you gain from using Git? What can you benefit from getting more into the version control system? So there's the feature branch workflow. So as I said, when there's like a new feature that you want to add to the project, you don't have to necessarily add that feature to the master branch or to the master. Okay, yeah, let's use the master branch in this case. So what you can do, you can just create another branch for the new feature that you want to add so that it doesn't mess up the master branch or like the project that it's like the version one of the project. So it doesn't mess up that thing. So you just create a branch and then you make changes to whatever file that you want to make change to. You add the feature and then when you're satisfied, or let's say, okay, now I've completed the feature. This is what I wanted to develop. That's when you can make your pull request and request for that feature to be merged to the remote repo, not to the master branch of the remote repo, to the master branch. And then there's distributed development. So as I said, you can have multiple users or multiple developers or people who are part of that project. You can have multiple people working on that project. So there's distributed development. Everyone who is part of the project has a local copy of the project in their local machine, and they make changes. They they run the Git add to interact with Git. Use those Git commands, letting other developers know that you've made changes to this file, so you want to merge it to the master branch and all that. So there's distributed development across the developers, project managers, whoever is part of that project. And then we have pull requests. Pull requests is basically just letting other developers know that you want to merge whatever change that you make to the master branch or to the project. So it's more like just notifying other developers or other people who are part of the project that you want to merge your changes. And then there's a faster release cycle because of the feature branch workflow, the distributed development, the pull requests. So all this adds to the release cycle, to a faster release cycle. So you don't have to spend like uh, months, years working on a project all over one, while you can interact with other people. You can work on that same project with other developers. So, and then the other thing that you can gain from using Git is building your code resume on GitHub. So eventually, you guys are going to graduate and enter the workforce, and having coding skills on a resume upon graduation is paramount for most of the big companies in the area and across the world. Because any other company around that's looking for like, developers, they can just go to your GitHub profile, go through your code, go through your reports, and see what you're capable of. So GitHub has become the platform of choice for showcasing coding projects to potential employers. So that's more like the social media for developers. So any other investors out there, or any other big company out there can just. So usually when developers apply, they include like their GitHub username on their resumes. So the company that you've applied to, you can just they can just go to your GitHub, go through your repos, go through your project, see what you're capable of, see your skills, how to hack eye, and then they can contact you. So that's more like your resume that's going to be there for years. So recently, GitHub introduced the active vaults, where all the code that you've written this past years, oh sorry, all the code that you've written this past years is going to be stored. It's going to be stored there. So, but better by one after. So after 56 years, the new generations will be able to see your code, the spaghetti code that you've written. They can refer to it, fixing that project, working on that school project. So they can refer to the code that you're writing now that you wrote 2 years ago. So it's gonna be there. It's gonna be there like forever. So and all the companies currently looking for developers, they can just go to your profile, see what you're capable of, and contact you. So I would recommend using Git if you manage a repo of code for an experiment or a project. So currently, I know that there's cool projects a lot. They are there right now. So if you manage So if you manage a repo of code for an ongoing experiment or a project as tool, you can use Git to write if you need help from someone else, most colon the lecturer or a student. They can just you guys can just collaborate on that one project using Git. So if you write a lot of complex and collaborative documents using LaTeX, you can use Git too. And as I said, you might need a portfolio of coding projects in the future. So I got to apply for like a developer role about like your project dealing in a zip folder or a USB. And then let's get into the basic terminology and the basic Git commands. So the first command that I'm looking into, by the way, you don't always have to use a Git commands. So if you're not comfortable with using Git commands, you can just there's the graphical user interface version of it where all these commands are more like automated. So you just click a button, create a commit message, and then yeah, the magic happens in the background. But using commands kind of gives you control over everything. Kind of like, it gives you like access to more functionality of it. So the basic Git terminology and commands, the Git init. So basically, this one just creates an empty repo on a local drive. So you can create a project locally, work on that project. If you run Git init, that's when you initialize a Git repo on your local drive or in that project. And then the Git status. This one displays the state of the working directory and the staging area. So you just let's you say the changes that have been staged, which haven't been staged, or which files aren't being tracked by Git. So it basically just gives you the status of your project as a whole. And then the Git add. The Git add basically is a change in the working directory to the staging area. So as I said earlier, you can when you run git add, you can either add a single file or you can add all the files that you've made changes to the staging area. It basically tells Git that you want to include updates to a particular file in the next commit. You have to add your files before running the git commit command. And then git add, as I said, this command right here, it adds all the modified and the new files in the current directory and all the subdirectory to the staging area, aka the index. So you can when you run this command, it compiles all those files that you've made changes to and it adds them. Then you can commit those files as one single commit. You can either add those files as a whole hollow one hela or you can add a single file or add two files. So you have to specify. And then the commit, before committing your files, you have to add them first. So the commit command is used to save your changes to the local repo and set. And then there's the git checkout command. This command lets you navigate between the branches. So you can check out a branch updates the file. Checking out a branch updates the files in the working directory to match the version stored in that branch, and it tells Git to record all the new commits on that branch. So as I said, if there's a new feature that you want to add or something new that you want to add to the project, you don't have to necessarily add it to the master branch. You can create a separate branch from that one, work on that branch, and if you mess up something on that branch, it's not going to affect the master branch. So after making all your changes, when you're satisfied, okay, this is what I wanted to add to the master branch. That's when you can create a pull request. That's when you can merge that one to the master branch. And then the git remote add. The git remote add takes two arguments. It takes a remote name, the name for the repo, and then, for example, origin. It takes a remote name, for example, origin, and then it takes a remote URL to that repo, which you can find on the source subtab of your Git repo. So there's a link that you can get that link points to that particular repo on the cloud. So it links your local repo, the local copy that you have on your machine, the version that you have locally with the remote repo that every developer who's part of that project interacts with. So first, when you add them, you add the files to the staging area, you commit them. The git remote add, you are adding them to the remote repo, not adding them to the local repo. So this remote right here it's gonna add those ones to the remote repo. So if there's something that you don't understand, you can just let me know, I can clarify. And then the git push command. So you run git add first, the git committing your files, and then the git push command, it allows you to send or to push the commits from your local branch in the local git repo to the remote repo. So to be able to push to your remote repo, you must ensure that all your changes to the local repo are committed. You commit your you commit all your files, and then you add a commit message. That's when you can push those files. So it's git commit, then add your commit message and those codes, labeling your commit, letting other developers know what changes you have made to that file. And then the git pull. The git pull is a combination of the git fetch and the git merge. So what git pull does, it pulls the master branch from the remote repo called from the remote code origin into your current branch. So you're just pulling the changes that other people have made to your current branch that you're working on. So it's a combination of the git fetch and then the git merge. So it just fetches and merges. And then when pulling those changes, you can come across something called a conflict. So there can be a conflict between the files that you're pulling that you want to merge to your local to the current branch, and then first before merging those files, you have to resolve the conflicts first. So Git can handle most merges on its own with automatic merging features. So a conflict arises when two separate branches have made different edits to the same line in a file. So obviously there's going to be a conflict if I and someone else on the other side have made different changes to one file or the same line in that file. So obviously there's going to be a conflict. So when a file has been deleted in one branch but edited in the other, conflict. Okay, no, this is just an example. Or there can be a conflict when a file has been deleted in one branch, but on the other side is still there and is being edited. So conflicts will most likely happen when working in a team in a team environment, because that's when someone else will be making changes to a file while the other one is making a different change to the same line as the other person. So there's going to be a conflict in that case. Before merging them, you have to resolve that conflict. And then git fetch. So the git fetch command, it downloads the commits, the files, and the rest from a remote repo into a local repo. So fetching is what you do if you want to see what everyone else who's part of that project has been doing. And then the git merge, you run this command after fetching those files. So you run git fetch and then the git merge. The merge command is used to integrate the changes from another branch. You can run git pull. Git pull is a combination of git fetch and git merge, as I said. And then the git revert. So the git revert command. This is a forward moving undo operation that offers a safe method of undoing your changes. So you're just basically reverting your changes. Instead of deleting or opening the commits in the commit history, a revert will create a new commit that inverses the changes specified. So this is a safer alternative to the git reset command in regards to losing your work. The git reset command itself, this is a powerful command that is used to undo the local changes to the state of a Git repo. So it operates on three trees of Git. These trees are the commit history, which is the head, the staging index, and the working directory. And then there's git rebase. The rebase command integrates changes from one branch into another. This is an alternative to the better known merge command. So most visibly, rebase differs from merge by rewriting the commit history in order to produce a straight linear succession. So, as I said, I won't be getting more into the Git command line interface, but after going through all these commands and after going through these commands, and then if you feel like you are comfortable with these commands, that's when now you can move more into using the CLI, the command line interface, which can give you like more control over your files. So the reason why I was introducing first before moving on to some other technologies on the agenda, yeah, the DSC, is because next up in like 2 weeks, I'm bringing the Android Study Jams. So first, we'll be using Git again when doing the Android Study Jam. So you have to be comfortable with Git, so it won't be that hard for you to push your code, to interact with other people, or to ask help in terms of code, anything else that you need help with more on your project. So in the coming 2 weeks, I'll be introducing Android Study Jams are going to be running like every Friday or every weekend. So I'll see which one fits best. We can either do them like every Saturday, 9 a.m., 11 a.m. So I'll try and see. So basically, let me share the screen for that one. Let me do this. Okay. Yeah, so this is what I'll be bringing, the Android Study Gems. So Android Study Gems is just community organized study groups for people to learn how to build Android apps using an online training course. So there'll be a training course that you guys will be following. I'll share the content with you when the time comes, so you can do it on your free time, and then when we go live or when we meet physically for the study gems, we can like review what you made, help you while you're struggling, then you move forward. So this is basically what we'll be working with. We'll be using Kotlin in this case. So there are 2 tracks. So if you're new to programming, there's some that's like material. Okay, there's the material that you'll be using that will be following if you're new to programming, and then if you have prior programming experience, there's something else for you. So if you feel like you don't have to start with the basic stuff, you can just go into that material that's like prepared for you if you have prior programming experience, and then this is basically for those who are new to programming, this is basically what you'll be working on. So we'll be learning the basics of building Android apps with Kotlin programming language and develop a collection of simple apps to start your journey as an Android developer. So I'll be inviting the Google Developer Experts, the GDG lead. So I won't be the one. Maybe in one session, 1 or 2 sessions, I'll lead those sessions. But there's a lot of people that I'll be bringing on board that will be leading the sessions. We have the GDEs, GDG leads, and all those, and you guys. So as I said in the info session, if there's like a technology that you want to introduce or something that you want to introduce, you can just hit me up, just talk to me. Inbox is always open. Just talk to me, and then we can organize a session for that. So you just need basic computer literacy, the basic math skills to start this journey. And then what will you learn? Introduction to Kotlin, create your first Android app, basic layout, adding buttons to that project, getting user input, display a scrollable list. So there's a lot of things that you'll be learning from this one. So this for people who are new to programming. And then if you have prior programming experience, check. So this is basically what you need. You have to be familiar with how to use an IDE, the development environment, familiar with GitHub. That's why I introduced Git first before getting into what will be coming. And then you need prior programming experience in an object-oriented programming language. And then I'll share the curriculum use. I'll be sharing the content with you so you can do all that. You can write code. You can go through the material in your free time. Uh, so yeah, this is basically what you'll be learning. That's why I said you'll be running for like every week So I'll see how to arrange it. I'll like draw up an agenda to follow, and then yeah, basically this is what I'll be bringing. And then at the end of this, let me share this out screen. Then at the end of these sessions, this is what I'll be giving out. There'll be a certificate of completion that I'll be issuing out to anyone who have completed the study jumps, who have been following, who have been part of the journey for all those weeks. So there's a certificate which you can add to your CV, to your resume when finding a job, to let the company that you're applying to, that you have let them know that you have experience in programming, you've worked with programming before. So just a certificate for completion of the Android Kotlin fundamentals course through the Android Study Jump program. So Google will be supporting this. And then yeah, I'll request for ones too. So if you need like help with internet or data, we can organize that one, and then you can be part of the journey too. And then at the end of that, you build a project. I review the project, and then I give you the certificate that you can add it to your CV. So yeah, basically this is what I had for you today. So if you have any questions regarding Git, regarding the Android study gems, you can just leave a comment here and I'll answer to you right now. So now I'm just leaving it to you right there. So if you have a question, just yeah, hit me. So my inbox is always open. You can just hit me up anytime if there's something you need help with. If, as I said, there's something that you want to introduce, a new technology, so you can just hit me up anytime. We organize a session for that, and yeah, we'll bring it to life. Okay, so if we don't have any questions, so that's what I have for you today. Thank you for joining me on this live. You can hit me up in my inbox. I'm available anytime, 24/7. You can hit me up and we see what you can work with. So thank you guys for joining the live session. I'll see you in the other session. That'll be coming, the Android Study Jam session. I'll collaborate with this. By the way, these are the DSC in use too. So I think in the coming sessions I'll bring him on board too. Then we can like organize sessions together. We can bring a collaborative session, and then I can contact the other DSCs in Southern Africa. We can organize collaborative sessions, and then yeah, we bring technologies to life. So thank you guys for joining me in this live. Peace out.